So recording is started. So let me start the class officially. So good morning, students. This is our class of geotechnical engineering. So till now we have completed the first module and second module, that is origin of soil, index properties of soil. Okay, and finally permeability of soil and seepage analysis of soil. Okay, seepage analysis. Okay, and about the last module, so I'll provide the notes. So don't worry about that. Today in this class, we are going to discuss one numerical of the first model, that is index properties of soil. Okay, so let me first share my screen here. So my screen is visible. I hope my screen is visible. So I have prepared one basic a very basic numerical for you, and it is related to the index properties of soil, that is under the module 1. Okay, fine. So let me first discuss with you about the problem statement, what is given in the particular problem statement. So here, I think you can read it out also. Just check it one more time. So in the problem statement of this numerical, it is given as a soil sample in its undisturbed state was found to have volume of 105 centimeter cube and mass equal to 201 gram. Okay, and after oven drying, the mass got reduced to 168 gram. So you need to compute, or you need to determine W small e, small n, AC, and capital S. I hope you remember what this symbols means. Okay, so if you know, you can write in chat box what is W means, what is E means. Okay, anyone? What is W means, or what is uh yo? What is small e means? Anyone? W, E, N, AC, and S. You need to find out this. Anyone want to answer? Either you can just speak or just write, whatever you want. So till then, I'll just explain the problem statement here. So in this problem, a situation is given to you, that is there is a soil. Undisturbed soil means a soil which is not disturbed by any means. It's a natural soil, or a soil which is in a natural condition without disturbing by external force. Okay, so in an undisturbed condition, a soil was found to have a volume of 105 centimeter cube. Okay, so if you can draw a phase diagram, if possible, you can also draw a phase diagram. So you remember the phase diagram, no? Like this kind of phase diagram is there, no? So it is a volume of solid and it is volume of voids, and the whole is what? Total volume, isn't it? Or like that, isn't it? I think you remember this. So what is given here? A soil sample in its undisturbed state was found to have a volume of 105 centimeter cube. That is, the total volume of the soil, undisturbed soil, is given as 105 centimeter cube, and the mass is 201 gram. That is total mass. That is capital M, you can say, or total weight also you can say. Gram weight also you can say. Okay, the weight is given as 201 gram. Okay. So after oven drying, the mass got reduced to 168 gram. After oven drying, what will happen? After oven drying, whatever the moisture will be present, whatever the moisture was present in a particular soil may evaporate. Okay, the water will get reduced or it will expel out of the sample. So only weight or only mass remain in the soil mass will be mass of the soil solid. Okay. So after oven dry, whatever the mass or whatever the weight will remain in the particular soil mass, it is equal to the mass of the solid or weight of the solid, and which is given as 168 gram. Okay, this is the values or informations are given to you. Using these three information, you have to find out these five parameter of soil or in property of soil. Till now, no response. Why? Anyone? You don't know what is W? You don't know what is small e? Why? Anyway, it's up to you whether you study or not. Okay, it's your responsibility. I'm not going to, explain all in detail because it's already discussed with you. Okay. Anyway, so what is W? Small w represents what? Water content or moisture content. Small e represents what? Small e represents void ratio. Small n represents porosity. AC represents what? Okay. Y is very late response. Okay. You have to be quick. Anyway, good. N represents porosity. And what is AC? AC represents air content. Yeah. And what is S? What is capital S? What is capital S? No. Solid is not a property. How can you find out S? How can you find out solid? S represents degree of saturation. Okay. So you have to remember this. Without this, we cannot be, progress in the further. So these are the very important parameter of soil or important properties of soil. You have to remember this. Okay. Anyway, so here is the solution. So before drying, that means in natural condition or in undisturbed state, total volume, that is capital V, is given as 105 centimeter cube, and total mass is given as, or total weight, whatever you say, is given as 201 gram. Okay. And after drying, that is after oven drying, the mass of the soil is given as 168 gram. So this 168 gram can be represented by MD or WD, that is dry mass of solid. Okay, since after drying, water will not be present in that particular soil, and air have weight of negligible. So indirectly we can say total mass of the soil or total weight of the soil after drying will be equal to weight of the soil solid or mass of the soil solid, which is given as 168 gram. So these three parameters are given to you. This is the information is already you have. So using this, first you need to find out the moisture content or water content. Now what is it? How can you find out moisture content using these three parameters? Moisture content or water content is defined. What is the definition of water content? Moisture content is defined as a ratio of what? It is a ratio of weight of water by weight of soil solid. Okay, or you can say mass of water by mass of soil solid. So mass of water is you need to find out, and mass of solid is given as what? Mass of solid is given as 168 gram. So here is the formula. Water content or moisture content can be written as, can be find out by weight of water by weight of solid multiplied by 100, since moisture content or water content is represented in percentage. So what is how can you find out mass of water or weight of water? By this formula, that is total mass or total weight divided minus mass of the solid. Okay, so if you subtract mass of the solid or mass of the soil solid or mass of the dry solid, if you can subtract this parameter from the total mass, you will get mass of the water. Okay, and divide by MD, that is dry mass of the solid. So just all these three parameters are given to you. Not three, all these two parameters are given to you. Total mass is given as 201. Mass of the solid after drying is given as 168. So here also 168 multiply 100. So finally we will get moisture content or water content as 19.64 percentage. So you just do by yourself. Okay, find out if it may be wrong, but you find out correctly. So 19.64 percentage. Okay, so first thing is already find out, that is water content is already we got. So after that we need to find out void ratio, that is E. So anyway, before that, let's find out the dry unit weight of soil. So why we need to find out dry unit weight? Let's come to the second case, that is we need to find out void ratio. Okay, so with the value that we have, with the known value we have, you utilizing that for value only, we need to find out the next parameter, that is void ratio. Now we know this standard formula. Okay, that is gamma d equal to, that is dry unit weight of soil or dry density of soil can be find out by this formula, that is specific gravity multiply by the unit weight of water by 1 plus E. This particular formula is already given to you in the first 2-3 classes. Okay, just go through that. Okay, so using this formula, our main aim to find out the void ratio, that is E. Now in this particular formula, specific gravity, it is not given to you. Suppose it is not given to you in your particular problem statement, then you can simply assume a value 2.7. Okay, usually in particular problem, specific gravity will be given to you. Suppose it is not given to you, so in that case you can just take an assume value. Okay, an appropriate value, say 2.7 or 2.68, you can also assume. Okay, so let's, for this particular problem, let's assume capital G, that is specific gravity of solid as 2.7. Okay, so this is known to you. Unit weight of water, or you can say in gram per cc, or density of water, it is what, 1 gram per cc. Okay, so it is also have a standard value. Okay, so unit weight of water, it is 9.81 kilonewton per meter cube. In gram per centimeter cube, it will be 1. So 1 gram per centimeter cube. Okay, so here in this formula, capital G is known to you, unit weight of water is known to you. You need to find out void ratio, but this is also unknown for now. That is dry density of soil or a dry unit weight of soil. For that, you need to find out first dry density of soil or dry unit weight of soil. Okay, how can you find out dry unit weight of soil? Using this general formula. So by the definition of dry unit weight and dry or dry density, what is that? It is the ratio of dry mass by total volume. Dry density or dry unit weight will be dry mass by total volume, or dry weight by total volume. So in this particular problem, dry mass is given to you, that is what, 168. Here see, dry mass or mass of solid after oven drying, 168 gram. So let's put here 168 here, and total volume is given as 105. See, total volume is 105. So just putting this value here, you will find the value of dry unit weight or dry density given as 1.6 gram per cc. Okay, now knowing this value, just simply put the value here, and solving this equation, you will find out the value of E. You do it by yourself. That void ratio will be 0.68, 0.68. It is your value of void ratio. So for now, we have got water content and void ratio. Now these 3 parameters you need to find out. Okay, let's find out this thing also. Okay, next, after getting the value of void ratio, next we need to find out porosity. And we know the relation between void ratio and porosity. Okay, so how can you find out porosity? But if you know void ratio, simply using this formula, n is equal to E by 1 plus E. This is a relation between void ratio and porosity. So just simply you utilize this formula and put the value of E here and simply multiply by 100, since it is represented in percentage. You will get the value of N, that is porosity, is coming as 40%. Okay, so porosity is coming as 40%. So after getting the value of porosity, Next, we'll find the degree of saturation, that is uh, denoted by capital S. Okay. For that, we will use a very general and very important relation, ES equal to WG. This relation is also already given to you. ES is equal to WG. You have to remember this very important relation between void ratio, degree of saturation, moisture content, and specific gravity. ES is equal to WG. So from using this formula, in this particular formula, void ratio is known to you, moisture content is known to you, specific gravity is also known to you, and one is left, that is degree of saturation. Now simply using this formula, you can find out degree of saturation, that is S equal to Wg by E. So here just put the value of W, put the value of specific gravity, and the void ratio, you will get the value of S. Okay, and you will get in percentage 20, multiplying 100 with this formula, you will get the value in percentage 77.98%. That is degree of saturation of that particular soil is 77.98%. Okay. At the end, we need to find out air content. Okay, you can go by definition of air content. Okay, but there is a relation between air content and degree of saturation. Anyone know that relation between degree of saturation and air content? You can just write in chat box. I'm waiting here. So if you know degree of saturation, how can you find out air content? Anyone? Anyone can answer this? How can you find out air content? No one? What is the definition of air content? Or what is the definition of degree of saturation? At least you should remember this. What is degree of saturation by definition? What is degree of saturation by definition? Degree of saturation is defined as what? Weight of water by weight of volume. Sorry. Volume of water by volume of voids, isn't it? It is your degree of saturation. Degree of saturation represents how much water presents in voids. In same way, what is air content? Air content represents how much air presents in voids. Simple. If you remember the phase diagram, so let's suppose this is a phase diagram. This is a solid part, and this is total volume of voids. Suppose this is total volume of voids, this one, and this is volume of solid. And in volume of voids, it may be filled with water or air, isn't it? So let's draw again. So this is say volume of solid, and this is total is volume of voids, and this total volume of voids can be divided in two parts. One is volume of water and volume of air. Okay, so what is degree of saturation? Degree of saturation represents what? Volume of water by total volume, the volume of voids, VW by VV. And what is air content? Air content represents VA by VB, that is volume of air by volume of voids. So now if degree of saturation is given, or degree of saturation is known to you, can we find out air content? No one? Chalo, anyway, I'm expecting at least one response anyway. So we know degree of saturation plus air content is equal to 1. Okay, since both are defined with respect to volume of voids only. S represents volume of water by volume of voids. AC represents volume of air by volume of voids. This summation of these two must be equal to 1. Okay, so using this formula, using this relation between AC and S, that is, using the relation between degree of saturation and air content, you can find out the value of the unknown. That is, since S is given as 77 point some percentage, let's find out AC. We know AC equal to 1 minus S. So 1 minus, we'll put the value of S. So it will be 0.7798. Okay, multiply, dividing by 100. And then finally multiply by 100, since it is also represented in percentage. So finally you will get air content here. Okay. So if you sum it up, this and this, you will get 100%. Okay, since S and AC are defined with respect to volume of voids only. So you should remember these things. Okay. So this is a basics of numerical. This kind of numerical may come in even in your exam. So that's why I have given this. So I believe you try this kind of numerical by yourself. If you can't, if you stuck in some problem, you can uh, text me. So I'll solve that particular problem. I'll make you understand. Okay, but you have to, do practice using this formula. Okay. Anyway, so here I just want to close this. So in this class, I have tried to explain one numerical. So I hope you have got a little bit idea about how to solve a particular numerical. So before solving that, you have to understand that a problem statement, and most importantly, you have to remember the relation between the various index properties of soil to solve this kind of problem. Okay, it's time to go back to the to revise all the information that we have shared. Okay, because exam is very near to you. Fine, and if you got any confusion midway, just come back to me. Okay. So with this, I just want to close my sharing here. Okay. So let's take attendance now then. So with this class, overall we have completed our syllabus. Okay. Overall we have completed syllabus. If some classes left, we'll again go back to the revision classes. Okay. If you need it, we'll go for doing some numerical also. Okay. It's based on your suggestion also. Okay. If you need some revision, you can also text me. So I'll prepare this particular class for you also. Okay. So with this, I just let's stop my recording here. Then I'll take your attendance.